Hello everyone. Today we are going to look into some new problems on T distribution and as well as population problems. Let's start. In the previous class, we have seen about Z distribution and Z distribution tables. Now, some problems on T distribution. We know the condition for T distribution is the sample size is less than 30 and sigma, that is population standard deviation, is unknown. So we will implement T distribution. A company manufactures car batteries with an average span of 2 years or more years. An engineer believes the value to be less. It is less. Using 10 samples, he measures the average lifespan is 1.8 years and standard deviation is 0.15. At the level of 99% confidence level, is there enough evidence to discard the null hypothesis? Okay. What is the first step is null hypothesis is sigma is greater than or equals to 2 years, whereas null hypothesis is alternate hypothesis sigma is not greater than 2 years. So what is level of significance is 0.01. Since it is one-tailed test, how we know a one-tailed test? In alternate hypothesis, the value is less than, sigma value is less than 2. So this is one-tailed test. This is new value sigma, and in T distribution we need two values to find out T distribution table. One is alpha value, level of significance, and sigma value. New value, sorry. New is degrees of freedom, that is equals to n minus 1. And what is the fourth step? T star, that is equals to T alpha new, T 0.01 and n minus 1. What is n? N equals to 10. So 10 minus 1, that is equals to 0.01, comma 9. So from T distribution table, this is T distribution table. This is 9 degree freedom line. Out of 9 degree freedom line, we need this value 0.01 level of significance, 2.821. 2.821. So the value is here 2.821 minus this is also 2.821. Since it is symmetric, both values are the same. So let's calculate TC value. Formula is difference of means divided by standard error. Here we don't know sigma. We'll calculate using standard deviation. S by root n. S bar. What is S bar? That is 1.8 minus nu is 2 divided by standard deviation is 0.15 root 10. After calculation, we get minus 4.22. This 4. So this is sorry, not this one. This one minus 4.22. So the value is in the shaded region. Minus 4.22 is less than minus 2.82. So this is rejection area. Since TC is in rejection area, That means that is TC is more extreme than T star. So we conclude reject null hypothesis. That's it. Okay. One more problem. This problem is from classwork inference problem number 3. A university is concerned about whether the average classroom is greater than 30 students. A sample of 12 classes, they have the average size is 13.83. So n is equals to 12. The average is 13.83. X bar is 13.83 and standard deviation. Sample standard deviation. This is S is equals to 4.65. What is null hypothesis? He is saying that mu is equals to 13. He is concerned about whether it is greater than 13 or not. Null hypothesis is greater than 13. At the level of significance is 0.05. Since it is one-tailed test, we will take alpha value as it is not alpha by 2. 0.05. So T star, what is T star value? T alpha gamma T 0.05 gamma is n minus 1, 12 minus 1, that is T 0.05 11. That is equals to, from T distribution table, we have to see the level 11 line with 0.05 level of significance. Is it 11 or 12? Yeah, 12. So 11, this value 1.796. 1.796. So TC value is x bar minus mu divided by S by root n. 13.83 divided by 13, 4.61 by root. This is 12. We will get around 0.665, around 0.65. So let's draw a graph. Here T star value is 1.796. This is the area of rejection. We calculated 0.65. Since it is not in shaded region, we can conclude that since it is less extreme, we fail to reject null hypothesis. That's it. Today we'll see one new problem, p-value method. This is purely optional for 512, and if you don't want to look into it, you can skip this problem, but it is very important to understand the concept in p-value. Average weight of all residents in town XYZ is 168. So average is 168. This is all residents, means that is some population. So out of she measured 36 individuals, that is equals to n is equals to 36, and the mean x bar is 169.5. Standard deviation, this is standard deviation 3.9 sample, and level of significance is 0. Using p-value method, is there enough evidence to discard the null hypothesis? What they want to believe, She measured 36 bits. He believes true mean is true different. Mean is not 168. She believes mean is not 168. This is null hypothesis. This is alternate hypothesis. See, alpha value is 0.05. Since it is two-tailed test, alpha by 2 0.025 because it is two-tailed test. So before it is like what we will do in normal method, t value, t or z value will find out. In traditional method, we'll find out the z value since n is greater than 30. So z value from will get some table, and gc is equals to x bar minus mu by s by root n. After using this, we'll get some 2.31, and we know this is 1.96 from table. 5% of level of confidence, two-tailed test 1.96. Since it is inside outside the region, so we reject. This is what we do in traditional method. This is traditional method. Normally we use this type. Now we are going to see about p-value method. From table, G star value is G alpha by 2 is G 0.025 is 1.96. I think everyone knows how to check this value 1.96, and ZC value. From ZC value we'll get 2.31. From graph, this is 2.31, this is 0, this is minus 2. Calculated value, this is calculated. Whereas this value 1.96 is here, 1.96. So since it is in rejection area, this is rejection area, we reject it directly. Now 2.93, you have to look into 2.93 in Z table. What is the 2.31 value? This is 2.3, this is 2.3, and this is 2.30, 2.301. The value from this, from the left hand side to the right hand side, is 0.989556 from Z value to 2.31, 0.989556. Okay. What is the next remaining area? 0.1 minus 0.989 is 0.01044. Okay. What p value is nothing but area of rejection. What is p value? P value means area of rejection. What is area of rejection? This is area of rejection, and this is also area of rejection. The area of rejection is 0.01044 on left hand side, 0.01044 on right hand side. This is area of rejection. P value, that is 0.02088, is less than alpha value if 0.05. Therefore, we reject null hypothesis. This is how we do in p-value method. We'll calculate the area of rejection value, that is p-value. If the area of rejection value, that is p-value, is less than alpha value, we reject null hypothesis. This method is called p-value method, where p-value is nothing but the area of rejection. And let's see the inference 4, I think. A problem example 3. An alderman Ted claims during a campaign meeting that his opponent Arthur will get only 1/3 of the votes. He'll get only 1/3 of the votes. He is claiming that he'll get only 1/3 of the votes. That is population proportion. He is telling it 1/3 of a poll of 432 people. 432 people on a street says 162 will vote this opponent. So population proportion. Let me clear that P is sample population, whereas phi is population proportion. Sample proportion. Sample proportion. Phi is population proportion. So what is saying? 162 out of 432 will vote opponent. Using level of significance 0.01. Two-tailed test. So alpha by 2 is 0.005. Is there reason to believe Ted's claim? So what is Ted's claim? He'll get only 1/3 of the rule. That is null hypothesis. What is alternate? He will not get 1/3 because since it is two-tailed test, alpha is 0.01, 0.1. Alpha by 2 is 0.05. 0.05. So G star value is Z alpha by 2, that is Z 0.05, that is from table 0.05 value. 0.05. Let's see, negative table 0.05 here. Somewhere around here 0.05 value 1.64. 1.645. So VC, that is calculated Z value, formula is difference of proportions by standard error, same 1 minus 5 by n. What is P value? It's around 0.0325, 0.325. Minus 5 value is 0.333, 0.333 divided by root of 0.333, 0.667 by 432. That is equal to minus 0.221. In graph, what is the 1.645? This total test minus 1.645. So what will get? Minus 0.22. Somewhere around here. Minus 0.22. Since it is not in rejection area, since less extreme, we fail to reject null hypothesis. This is population proportion problems. And let's see two populations, two means in next class, and try to finish goodness of fit in next classes. If you have any doubts regarding p values, z, t distribution, populations, kindly let me know through email, or else you can meet me from Monday from 3 to 6, on Wednesday 3 to 6 at BECC 4232. Thank you so much.